So here's a relatively simple vector problem where we find the unknown values for our magnitude of forces for two separate vectors. Couple key points to note and remember throughout statics is that when something is in equilibrium, you'll always want to use the summation of forces in both the x and y direction, and that always needs to equal 0. So we'll use that in this problem. And another thing to note when it comes to vectors, whenever it's not perfectly aligned with either the x or y axis, you have to take into account the angle of change from the vector from the axes. And the way I kind of do it is if you're given an angle value like you are here, whatever axis that angle value is touching with the vector, that's always going to be a cosine value. So if you take a look at our summation of forces of x in this little example, where this is the force of this vector, in the x direction is touching this angle here, so it's going to be f cosine theta. Now if you're giving dimensions like a triangle here we have a 3, 4, 5 triangle, and with a base and height, typically you want to just match your, like the base would be equivalent to the x-axis. So if you're going to calculate the x-axis just using this triangle, you would just divide the 3 by the hypotenuse, which is 5, since 3 is on the x-axis. Now if you look at the y value, since there's no angle given that's touching the y value, you know that's going to be a sine then. So it's going to be f times whatever's the sine of this theta value. And then if you want to use the triangle method, the height value is equivalent to the y, so you'll just divide 4 over 5 and then multiply it by the f value. So we'll go ahead and get started on this problem. One thing to note about this problem is you're given a theta value, but it spans both these vectors here. So I mean, the first logical thing to assume is that it almost looks like it's split in half, so the angle here and here will probably be 45 degrees, but you can never make that kind of assumption. You always want to kind of double check it, especially since you're given these triangle dimensions here with an x and y value. You can calculate your angle value here for this first vector. So we'll go ahead and call that theta 1. And we just use our basic trigonometry rules to figure this out. So we'll just find the inverse tangent, opposite over adjacent. So that'll be equal to the tan inverse of 3 over 4. And you end up getting an angle value of 36.87 degrees. So it is not perfectly split in half. So for this vector here, we'll go ahead and call that angle theta 2. And you'll figure that out by, since we have a total angle between the two vectors, just subtract 90 degrees with 36.87, and you'll get an angle of 53.13 degrees. Now that we kind of have like these updated angles for our individual vector, we can go ahead and try to draw a new free body diagram. Just kind of update all the values we have, and it'll help us for our calculations so we don't get confused. So we'll do that real quick right here. So always make sure you label your axes. So here we have our x and y. And then this will be our vector b, and our vector c, Now for vector B, I'm just going to maintain this triangle shape instead of using 36.87 degrees because I feel it's cleaner for our calculations. And then we have our straight vector here, vector A. And then, so that's A, and that's equal to 9 kilonewtons. And then we'll call this FB, origin, and then TC. And then we have, this will be theta 2, which is equal to 53.13 degrees. Alright, so now we pretty much have everything that we need to solve this problem. So we know we have just two unknowns, so we know that we can label everything in both the x and y direction. So I like to just kind of outline everything first and then kind of figure out what the best method of solving it is. So we'll just start with the summation of forces in the x direction. Now when I do these, I like to show which way I'm thinking or which way I'm using as a positive direction. So for x direction, it's left to right, and then I go ahead and start my summation problem. And then, oh, I forgot to label this here. So it's 4, 3, and 5. Since we're going in the x direction here, like what we explained earlier, I'm going to use this 4 value and divide it by the hypotenuse. So it'll be 4 over 5 FB. And since our vector is going left to right, that's positive. And then if we look at our TC vector here, it's also going left to right, so that will be positive as well. Plus TC. Now we look at our angle here. It's touching the x-axis, so we know that's going to be a cosine. So that's going to be TC times the cosine of 53.13. And that's equal to 0. Now we're in our y direction. My positive is going to be going up. Now for FB, you can see that we have a y value of 3 on the triangle, so we'll divide that by 5. Now for our TC vector, you can see it's going in the negative direction here. So we'll subtract that, TC. And since this angle isn't touching the y-axis, you know we're going to use the sine of that angle. So it'll be sine 53.13. And typically that would equal 0, but remember we have this a vector here that's going straight up and down. So that's a negative 9 value. So instead of writing minus 9 is equal to 0, we'll just go ahead and add it to the 0. So we'll just equal this to 9. Now you can see here that we have a perfectly aligned equation. You can solve this a few different ways. You can use either substitution, solve for one variable, and then substitute it in the other problem. Or you can use some linear algebra instead of a matrix C. If you have a matrix C program stood up in your calculator and your teacher allows you to use that, then I mean that's great as well. I'm not really going to go over that here because that's a lot of mostly just algebra. So I'll just go to the answers. So our F value is equal to 5.40 kilonewtons. It's going in this direction. And our T value is equal to negative 7.2 kilonewtons. And since we had a negative value here, we'll end up going the opposite direction. So that's pretty much it. The main thing is to just double check your angles, and then just also understand that just have an understanding of your Cartesian system, what's going in the positive direction, what's going in the negative direction, and then that'll allow you to kind of line your problems up cleanly to where you can solve for it using either algebra or your calculator, and you'll be able to find these force values relatively quick. Also, just remember that whatever angle is touching the axis, that's going to be your cosine value for your angle. And if you use this triangle method instead, just line up whatever axis you're using. So for the x value, just line up the 4, because that's the x value of the triangle, and then divide it by the hypotenuse.